Hello everyone, welcome to Canal Physics. Today we are looking at the International System of Units, or SI units.
If you ask a professional 10-pin bowler in England what the mass of a bowling ball is, they might tell you it's around 10 pounds. But if you ask the same question to an Australian professional 10-pin bowler, he or she might say about 4.5 kilograms. This is just one example of units of measurement being different in different parts of the world. But to ensure effective and efficient communication between scientists around the globe, the International System of Units is used. This is also called the SI unit system. This was adopted globally by scientists in 1960, and it is the modernized version of the metric system. So as we covered in the Introduction to Physics video, there are fundamental quantities and derived quantities. Essentially, the derived quantities come from a combination of the fundamental ones. So in this table, we see the 7 base units of the International System of Units, or the SI system. And all other derived quantities come from a combination of these 7 base units. So for example, area is square meters, that is just meters times meters. Another example is density, that's kilograms per cubic meter. Or speed is meters divided by seconds, or meters per second. So what is the significance of the SI unit system? Well, for you as a student, it's important you know that these are typically the units we use in formula.
This table shows a select list of derived quantities with their corresponding SI units. We can see from this list that some of these quantities have a special name for their unit and corresponding special symbol. This is usually named after a scientist. So for example, force is measured in newtons, and we use a capital N to symbolize that. But one thing all of these have in common is that they have a fundamental composition. So this is just the fundamental breakdown of their SI units. And all you're ever going to find here is a combination or some combination of the 7 base units from the previous page. And in this list I've chosen to show you, you'll only see meters, seconds, and kilograms here. And these are the ones we regularly use in physics. But there are countless others. By all means, I can't show all of them in this one table. One interesting thing to note is that of the 7 base units, the fundamental units, the kilogram is the only one that has a prefix in it. And it's okay if you don't know what some of these are or if you've never heard of them, because we're going to cover these concepts more in future videos. Although the SI units are the ones used in formula, here is a select list of fundamental and derived non-SI units. The reason it's good to be aware of these is that they are often mentioned in problems. So your job as a student is usually to convert these into the SI units so they're ready to put into the formula. So what we have in the columns is the fundamental quantity name, the unit, the non-SI unit or units for these quantities. I've just included some common ones here, and their symbols and common conversions that you will be required to do. And if we look at the table below with the select list of derived quantities and their non-SI units, we can see that speed is often quoted in kilometers per hour in physics problems, especially if it's something like a car or an airplane. But your job is to convert this into meters per second because that is the SI unit. And we will learn how to do that in future videos. Let's do an example. Here we are asked to calculate the density of this cube, which has a side length of 4 centimeters and a mass of 150 grams. But the units for density must be in SI units. So let's start by converting the mass into kilograms. So 150 grams, if we want kilograms, we divide by 10 to the power of 3. So that's 0.15 kilograms. And the side length is 4 centimeters. And we can convert that to meters, which is the SI unit for length, which becomes 0.04 meters. So we did that by, remember, prefix is centi, so times 10 to the negative 2 to get our answer there, which is essentially dividing by 100. And what's nice about this is we have the formula for density provided. Now this is quite normal in physics. You will get a list of formulas and constants that you need that are commonly used in tests and exams. But you can see we need the volume to calculate the density. So the volume of a cube is simply the side length cubed. which is 0.04 cubed, and this gives us 6.4 times 10 to the negative 5 cubic meters. So this is good. We've now got our mass and volume in SI units. Now we can calculate density. The symbol for density is Greek letter rho, which is like a slanted lowercase p, and that is going to equal mass divided by volume. So volume is capital V. Lowercase v is used for speed or velocity, which we will come across in future videos. But now we've got both of these in SI units, we can divide them. Just make that a bit longer there. Putting this into our calculator, we get 2343.75. And this will be kilograms per cubic meter. Before we write our final answer, we must consider how many digits to write. So remember, we divided mass by volume. So since it's divide, we must go by the lowest number of significant figures from our original data. 150 has 2 significant figures, 4.00 centimeters has 3, so our final answer must be the lowest number of those out of those 2, which is 2 significant figures. Now we have 2 options here. We could write this as 2,300, round to the nearest hundred, or we could write it as 2.3 times 10 to the power of 3 using scientific notation. Either way, both are 2 significant figures. And I'll just complete my working there. So either that one or that one, and that's it. Lastly, it's worthwhile knowing some conventions when writing units, quantities, and prefixes, especially their symbols. Let's start from the top. Units are always written in singular form. So when writing the symbol for kilometer, we write it as km, never kms. Even though it might be more than 1 kilometer, we still write 2 km or 3.5 km. And this goes for any other unit. Also, units are written in index form. So instead of writing m/s for meters per second, it's more professional to express it as ms to the power of negative 1. Which is the exact same thing. Quantity symbols are italicized, so we know mass has a symbol lowercase m, and that is italicized. Now, my handwriting in videos will not do this justice because I'm not going to write in italics and not italics, it'll just be my handwriting. But when you see typed out symbols for units, quantities, and prefixes, this is where it'll become more apparent. So following on, unit symbols and prefixes are not italicized. So the meter, which is also represented with a lowercase m, we don't italicize that because this is a unit. And there's also an m for milli, which is a prefix. That also is not italicized, just like any other prefix. And we have a space between different units. So when we have multiple units next to each other, we put a space between them, like we see here with, again, meters per second. This is good, it's in index form, it's not with that yucky slash in the middle. But also the m and the s, since they're both different units, meters and seconds, we put a space between them, if you see that little space there. And on the contrary, we don't have a space between a prefix and a unit. So if you've got the milli and the meter to make millimeter, that's a prefix next to a unit, so there is no space there. And of course, neither of them are italicized because that's a prefix and a unit. So below we have a good example to see how all these rules are at play. So we see lowercase v represents the speed. This v is therefore the quantity symbol. And since it's a quantity symbol, that's why it is italicized. And the quantity is speed in this case. And we see on this side, we have so this whole thing here, we have the unit symbol. And the centimeters per second, this is the centimeters part, that's not an SI unit, but the seconds part is. But the reason I show you this example is we kind of see everything here at once. So
we've got a prefix, and that's why we don't have a space between the centi and the meter, because that's a prefix in a unit, and they're not italicized. And also the last part of this unit is the seconds, or the seconds to the power of -1. That's also not italicized, because that's part of the unit still. And just learning a little bit more vocabulary here. So we refer to the actual value of this quantity as the magnitude. So this can also be said as the amount of. So that's the amount of speed of that particular object, the magnitude.
Thank you for watching this video. If you found it helpful, please like and share it, and subscribe to my channel for more.